This is Mr. Gillum, and I'm going to do an example for you out of your practice and problem solving book on page 67. The example says this. The students in Mrs. Marco's art class use 5 jars of paint altogether. Each student uses 1/3 of a jar of paint. How many students are in the class? To answer this question, you need to find out how many thirds are in 5. You can draw a model or you can use an expression. And by doing either of these things, you can see that there are 15 students in Marco's art class. So a lot of times students don't like to model or take the time to model. So let's start this one with an expression. It says that they use 5 jars of paint. It doesn't say that they have 5 jars of paint. It says that's how much they actually use. It says that each student uses 1/3 of a jar of paint. So I know that I need to know how many 1/3 went into 5 to see how many students actually completed the art project. So I could divide 5 by 3, by 1/3. We know from the notes coming to class today that that is the same as 5 being multiplied by 3, or 5 over 1 times 3 over 1, which is 15. So there must be 15 students in Mrs. Marco's art class. Each of those 15 students used 1/3 jar of paint. They would have used 5 jars of paint altogether. A way to model this would be like this. We can model the 5 jars of paint. And if we need to know how many 1/3 there are in 5 jars of paint, I would chop them into thirds. If we need to know how many 2/3 were in 5, I would still separate them into 1/3 pieces. I would just count every 2. In this case, though, it's just every 1/3. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They must have 15 students. If each of those students use 1/3 jar of paint, for them to use exactly 5 jars of paint altogether. Okay, so there's a model example and the expression example with the keep, change, flip method, known as a multiplicative inverse, and that's it for today.